In this question, you are required to solve for D. Now, let us start. Solution. Here, we break this 9 into 3 raised to 2, so as to have the same base as this one. Now, 3 raised to 2, we get 9 times D, as there is D, is equal to 3 raised to D plus 6. Here, it is the same as the one who will write this way. 3 raised to D times 2 is equal to 3 raised to D plus 6. Let 3 raised to D is equal to K. Now, we are going to substitute K into 3 raised to D. Now, we're going to have K square is equal to 3 raised to D, where we have said that is equal to K, is equal to K plus 6. Now, let us form a quadratic equation this way, K square. I have taken K and 6 to the left-hand side. That's why I have obtained this quadratic equation. Now, we are going to solve quadratic equation to look for K. When you solve for K quadratically, you get that K is equal to 3 or negative 2. But remember, in our question, we are not required to look for K, but we are required to solve for D. Now, we have already said that K is equal to 3 raised to D. Now, for where there is 3 raised to D, we put the value of K, which is 3 or negative 2. Now, 3 raised to D may be equal to 3, or 3 raised to D may be equal to negative 2. For this case, 3 raised to D is equal to 3. It means that 3 raised to D is equal to 3 raised to 1. The same base is the same exponent. So it means that even the value of D will be equal to what? To 1. So here, D is equal to 1. For this case here, 3 raised to D to be equal to negative 2, this is impossible, because there's no way we may have an exponent whether negative or positive raised to the base which is positive, and you get the answer which is negative. You will never get that answer of negative for the positive base to any exponent, whether negative or positive. So this one is impossible. Now the value for D is equal to positive 1. Thank you.